All right, moving forward with our advanced chemical reaction. Today is going back to the PowerPoint again. This one's actually going to be fairly short for a change. You only have a few slides you have to look at. We're going to talk briefly about this idea of neutralization and then what a titration lab is. So, if you're looking at your PowerPoint, neutralization is probably exactly what you're thinking it is. You are neutralizing something. But the word neutral is what I want to touch on real quick. We have this bad habit when we teach acids and bases where, and we talked about this in the last lesson, you think that something is an acid, it's a base, or it's neutral, and you think that what that means is this has these H3O pluses, this has these OH minus, and this has nothing. And like we learned before, that's not true. Okay, the self-ionization of water means water plus water is going to dissociate to make those hydronium ions. I don't know why I just put that 3 up top. Sorry. Hydronium ions and hydroxide ions. So we know that if something is neutral, what that really means is that we have an equal concentration of hydronium and hydroxide. That's a very important concept to remember. Neutral does not mean nothing's in there. It means there's an equal amount of both. So if you take a strong acid, hydrochloric acid, and you mix it, with a strong base, sodium hydroxide, it's a double replacement reaction. We learned about this earlier. But in this double replacement reaction, this Na and this Cl, they get matched up, and then you get this H and this OH matching up, which is really making water. So we go from potentially dangerous to harmless unless you put it on a slug, and harmless unless you chug like 9 gallons. That's the way this works. Now you know common sense wise it's not really that easy. You put these things together, you are going to have one heck of a reaction. But the reality is a neutralization reaction, you are having these things cancel out, okay, the acidity and the basic are canceling each other out. It's a very common way to deal with acid and base spills. One of the most common ones that you'll see used is baking soda. When we did that lab with aluminum foil and hydrochloric acid, you saw me use baking soda. And baking soda is one that you need to recognize its formal name and formula. I'm never going to ask you for it, but it would not shock me if your SOL did. So baking soda is sodium bicarbonate, otherwise known as NaHCO3. That's how we can deal with acids. We add a little base to them, and if you remember the hydrochloric acid aluminum foil lab, it sizzled, it bubbled, it steamed, but then the pH got balanced a little bit. Okay, when you add those two things together, you're bringing the pH to the middle of the scale. So, one thing that we see with neutralization reactions is lots of times we'll use something called an indicator. An indicator changes color at a certain pH level. Your PowerPoint lists several: red cabbage juice, litmus paper. The one we use the most is called phenolphthalein. Phenolphthalein is pretty cool. When you put it in a base, it turns pink. It's totally clear when you see it normally. You put it in an acid, maybe it gets a little cloudy, but for the most part it stays clear, but it is neon pink when you put it in a base. So one of the labs that you need to know something about for your SOL is called a titration lab. A titration, there's a great picture of it in your PowerPoint, but it is used to determine the unknown concentration of a known reactant. The idea with a titration, I'm going to try to draw, this should be painful, is if you have an unknown down here in your Erlenmeyer flask. Okay, so let's say I know for a fact that this is hydrochloric acid, but I have no idea what its concentration is. I don't know if it's strong, I don't know if it's weak. The idea with a titration is we can set up one of those burettes like we were using the other day. Okay, so we'll take a little ring stand here, and we'll put a little clamp coming out of it like we did the other day, and we'll have the little burette going right down here into this flask. Remember, burettes are those little things, they've got the stopcock down here, I know you remember that word, and we go drop by drop putting in whatever's in there. So there's my HCl. The way a titration works is I will put sodium hydroxide and you can use other things, this is just what I'm using, I will put a known quantity, known concentration of sodium hydroxide in this flask. So let's say I use 1 molar sodium hydroxide. The other thing that I will do is I will then put an indicator down here in this acid. And phenolphthalein is one of the most common ones. Phenolphthalein lots of times is abbreviated as PTP, just because nobody wants to write out the word phenolphthalein. Do you blame them? It's huge. But we'll put that down in there. So think about this for a second. Right now, there is way more acid down here and way more base up where it's blue. Okay, with phenolphthalein in there, phenolphthalein only changes colors when I have a basic pH, when it's above 7. Well, right now this pH ain't above 7. So I'm going to drip my sodium hydroxide down in there. Sometimes you see a flash of pink as it combines with the phenolphthalein, and then it disappears. Because as I add this acid, that acid and that base end up kind of combining together and canceling each other out. And as long as I have more acid than I do base, my pH stays acidic, nothing turns pink. But as I keep going and keep going and keep going, and I've got my acid and my base, and they're canceling each other out, I'm getting closer to where this thing is neutral. And that's the idea here. I'm trying to neutralize this acid. So as I keep going and get closer and closer and closer, I watch the pink. It'll stay pink for longer, and then it'll go away. Then it'll stay pink for longer, and then it'll go away. My idea is to find what's called the equivalence point. Okay? The equivalence point is the point at which the amount of my acid is equal to the amount of my base. That's when I've created a neutral solution in this flask. The problem with the equivalence point is I can't see it. Okay? I can't tell it's equal. I can only tell what's going on when I have my base greater than my acid, because that's when this whole solution will turn pink. If I go too far, I don't know where that equivalence point was. So your goal when you're doing a titration is to go 1 drop past your equivalence point. That's what you want to do. Because remember, okay, your equal or your equivalence point is where your moles of your acid are equal to the moles of your base. So for example, if I know that in my titration I ended up adding 4 moles, actually let's go back a step. If during my titration I know that I added, let's say based on my burette, 14 milliliters of sodium hydroxide, okay, I can convert that to moles. Okay, it's something that we're going to talk about in class some. You can look it up and you'll read a little bit more. But I can look up my concentration here, figure this out. But if it took 14 mils of NaOH that was 1 molar, okay, in fact, I'll do this for you guys right now. Molarity is equal to moles per liter. So if it took 14 milliliters of 1 molar, okay, 0.014, that means it took 0.014 moles to get 1 drop past that equivalence point. Then I can go 1 step farther. This is my base. This is my NaOH. But we said that the equivalence point is where your base is equal to your acid. So that means I must have had 0.014 moles of hydrochloric acid. And if I knew that there was originally, say, I don't know, 25 milliliters of that hydrochloric acid in there, then I could say, okay, molarity is moles per liter. I don't know my molarity, but I know I had 0.014 moles. I know I had 0.025 milliliters. That's my known. What that just told me, if I go to my calculator, is 0.014 divided by 0.025. I had a 0.56 molar solution of hydrochloric acid. Again, what I did is I introduced the base to the acid, tried to find the point at which they are equal, and then go 1 drop past. So this isn't the exact molarity, it's 1 drop off. But 1 drop is not enough to really matter. So that's neutralization and titrations. It's a lab that the SOL may ask you about, just with the basic setup and the basic calculations of what's going on.